Hello, welcome back to Vedantu's NCERT Solutions for class 11 and 12. We are going to discuss the very first question from D and F block elements. So NCERT question 4.1. Write down the electronic configuration of these elements. So we need to write for chromium 3 plus, and we have promethium 3 plus, and we have copper plus, and cesium 4 plus, cobalt 2 plus, and we have lutetium 2 plus, and manganese 2 plus, and thorium 4 plus. So in here we are going to discuss the electronic configuration. Basically, what is electronic configuration? It's nothing but it's the symbolic representation or notation of the manner in which the electrons are arranged in the or distributed in the different orbitals. So we are going to write for one by one. So for chromium, the atomic number is 24, and the electronic configuration of chromium is argon 3d5 4s1. So what is the electronic configuration of argon? It is 1s2 2s2 2p6 3s2 3p6 3d5 and 4s1. It is 3d5 and 4s1. So if we remove three electrons from chromium atom, it's going to be argon 3d3. This is the electronic configuration. So 1s2 2s2 2p6 3s2 3p6 3d3. This is the electronic configuration of chromium 3 plus. Chromium 3 plus. So let's move forward to the second one. Second one is promethium. Promethium. So pm3 plus. This is the element that has been given, the ion. So atomic number of promethium. Atomic number of promethium is 61. So the electronic configuration, xenon 4f5 6s2. So pm3 plus, the electronic configuration is going to be xenon electronic configuration followed by 4f4, and it is going to be, yes, as there are 3 electrons that are removed, it is going to be 4f4. So let me write the configuration of xenon, and yes, 1s2 2s2 2p6 3s2 3p6 3d10. we have 4s2 then, and then we have 4p6 4d10. we have 5s2 5p6. This is the electronic configuration of xenon, and then we have promethium, so it is 4f4. This is the electronic configuration of promethium 3 plus ion. And while we are writing the electronic configuration, we need to follow this rule, the diagonal rule. Alright, next one is, the third one is copper plus ion. So atomic number of copper is 29. So the electronic configuration of copper will be argon configuration followed by 3d10 4s1. As we are going to remove one electron, Cu plus ion, so one electron is removed, so it is going to be argon 3d10. 1s2 2s2 2p6 3s2. we have 3p6 and 3d10. This is the configuration of Cu plus ion. Next we have cesium 4 plus ion. Cesium 4 plus. So it is Ce 4 plus. Atomic number of cesium is 55. Atomic number of cesium is 55. So xenon, cesium, xenon followed by, we have, so cesium has the atomic number 55, and the electronic configuration will be, so yes, 54, xenon 54. So cesium can lose only one electron, okay, and it will become stable. So the electronic configuration will be 1s2 2s2 2p6 3s2 3p6 4s2 3d10, and we have 4p6 we have 5s2, 4d10 and 5p6. So this is going to be the electronic configuration. Moving on with the fifth one. So which is the fifth one? It is cobalt 2 plus. It is cobalt 2 plus. So the atomic number of cobalt is 27. So cobalt 2 plus, its electronic configuration is going to be argon 3d7. In detail, so 1s2, 2s2, 2p6, 3s2, 3p6, 3d7. So this is the electronic configuration of cobalt 2 plus. Alright, so how many number of electrons are there? Let's see. 2 plus 2, 4, 10, 12, 18, and then we have 18 plus 7. Okay, so there are 2 electrons that are being removed. So it's right. Next one. Sixth one. It is lutetium, Lu2 plus. It is lutetium. And the atomic number of lutetium is 71. Number of lutetium is 71. So the electronic configuration of lutetium 2 plus will be xenon, followed by, so 54 is the atomic number of xenon, followed by 4f14, 5d1. This is the electronic configuration. The lutetium electronic configuration, the elemental configuration is lutetium. So it is xenon 54, 4f14, 5d1 and 6s2. Okay, as we have removed these 2 electrons, it is 4f14, xenon followed by 4f14 and 5d1. Then we have the seventh one. Seventh one is, we have manganese 2 plus. This is a very simple one. Manganese, the atomic number of manganese is 25. Atomic number of manganese is equal to 25. So manganese electronic configuration, argon followed by 3d5, 4s2. So as we are removing 2 electrons, it is argon 3d5. That's it. Last one, eighth one, is thorium, Th4 plus. It is thorium. The atomic number of thorium is 90. Atomic number of thorium is 90. So thorium 4 plus, its electronic configuration will be radon followed by 6d2, 7s2. So it is 62 and 7s2. So radon's atomic number is 86. Okay, so 86 plus 4, it's going to be 90. So it's the general electronic configuration. So thorium 4 plus, it is going to be radon, yes, 86. This is the electronic configuration. If we write in detail, so it is going to be 1s2, 2s2, 2p6, we have 3s2, 3p6, and we have 4s2, 3d10, 4p6, we have 4d10, and we have 4f14, and we have 5s2, 5p6, 5d10, 6s2, 6p6. This is the electronic configuration of thorium 4 plus ion. So we have discussed about a couple of ions as of now. So this number represents how many electrons are being removed. So if it is in negative charge, 3 minus or 2 minus, the electrons are being added. If it is in plus charge, so these metals are capable of losing electrons. They form cations. They form cations upon losing electrons. So this is about the very first question, the electronic configuration of the respective ions. Thank you.